Hello students, how are you? Finally I am ready now for making video class for you. So this is the only way to continue our classes during this pandemic of coronavirus, right? Okay. Now without losing our time, I'm going to start a very easy and mark scoring chapter. I think the chapter number is 4 and the name of the chapter is chemical kinetics, right? Chemical kinetics. So the name of the chapter, if it is chemical kinetics, from its name we can easily understand what will be the topics we'll discuss in this chapter, right? So the term kinetics means speed or rate. So kinetics means speed or rate. So chemical kinetics means we'll study the speed or rate of a chemical reaction. All right. So the best term will be the rate of a chemical reaction, right? So in our laboratory we will find some of the reaction will occur very quickly and some of the reactions will occur very slowly, right? So the reaction which occurs very quickly we'll call the rate of the reaction is more, or if the reactions occur very slowly we'll call the rate of the reaction is low. So in this chapter, so first we'll know what is a chemical reaction, right? What is a chemical reaction? A chemical reaction means, suppose if we add two chemicals, suppose one chemical it is A, another chemical is B. So when we add these two chemicals, they will react with each other and will form another chemical, that is, suppose it is C, right? These two chemicals which are reacting with each other, these two are called what? Reactants. And the new chemical is forming in the reaction, it is called product, right? So in a chemical reaction, two chemical reacts and another chemical is formed. So the reacting chemicals are called reactant and the forming chemical is called product. Okay, so in a physics, if we discuss about speed, okay, what is the formula for calculating speed of a particle? You can say particle or anything, the speed. How to calculate the speed? The formula was dx by dt. This means if a particle or if a matter is moving from one position to another position with the time interval of t, right, the speed we can calculate the change in the position of the matter and the time interval. If you divide the position of the matter with respect to the time interval, we will calculate the speed of that matter. All right, but in a chemical reaction, how we will calculate the speed or rate of a chemical reaction? So in a chemical reaction, remember one thing: the amount of the reactant, these two reactants, suppose in this reaction, the amount of the reactant will always decrease. In a chemical reaction, the amount of the reactant will always decreases and the amount of product will always increases. All right, so this is the main point you have to remember for this chapter. Okay, the amount of the reactant will be decreased and the amount of the product will be increased. Now in a chemistry, the amount term is not a suitable term for a chemical reaction. In place of amount, we will say it is concentration, right? In place of amount term, we will call it is concentration. That is, the concentration of the reactant will always decreases and the concentration of the product will always increases in a chemical reaction. Okay. And the unit of the concentration is mole per liter. Everything has a unit. Suppose the unit of amount, maybe it is gram, kilogram, or in case of volume, liter, milliliter. So similarly, in case of concentration, there are many unit for concentration. One of the unit is mole per liter. Right? So in a chemical reaction, the concentration of the reactant will always decreases and the concentration of the product will always increases. This is the main point you have to remember. Suppose these are the two reactants and P it is a product. Suppose at the earlier we took 10 mole per liter of A and 8 mole per liter of B. At the beginning we took 10 mole per liter of A and 8 mole per liter of B. And at the beginning the amount of product or the concentration of the product was 0. At the beginning of the reaction, the concentration or amount of the product was 0 mole per liter and the concentration of A and B is 10 mole per liter and 8 mole per liter respectively. Alright. So after some time, when they start reacting these two reactants, the concentration of A will decreases and concentration of B will also decreases and the concentration of the P will increases from 0 to some values. Suppose the concentration of A decreases from 10 to 7 mole per liter and the concentration of B is decreases from 8 mole per liter to let it be 5 mole per liter, and the concentration of P increases from 0 to suppose 2 mole per liter. So how we will calculate the rate of this reaction? So remember, so rate of the reaction will be change in the concentration in the reactant divided by time interval, or change in the concentration in product divided by time interval, right? All right. So first, to calculate the rate of a reaction, we have to understand the change in the concentration of the reactant within the certain time interval and also change in the concentration of the products within a time interval. Right? Suppose for this example, the initial concentration of A reactant was 10 mole per liter and after some times the concentration of A was decreases from 10 mole per liter to 7 mole per liter, and this will be the final concentration of A and this will be the initial concentration of A. Similarly, 8 is the initial concentration of B and 5 is the final concentration of B, and 0 was the initial concentration of P, and that is product, and 2 mole per liter was the final concentration of the product. Now to calculate the rate of a reaction, we have to calculate first change in the concentration of the reactant or change in the concentration of the product. Suppose at the initial time, when the reaction just started, we will took time is equal to 0. That is just reaction, just we had mixed this to a reactant, but reaction has not started yet. Suppose after time 5 minutes, the concentration of A decreases from 10 to 7, and B, concentration of B decreases from 8 to 5, and concentration of P increases from 0 to 2. In case of product, it is always increases. In case of reactant, it is always decreases. Right? So we will first calculate change in the concentration of the reactant. How much the concentration of the reactant has changed? In term of A, how much the concentration has changed? It was initially 10 mol per liter, changed to 7 mol per liter. So what will be the change in the concentration of A? Concentration of A will be what? How to calculate the change in the concentration of A? Final concentration of A minus initial concentration of A. This will be the change in the concentration of A, that is final concentration of A minus initial concentration of A. And the time interval will be what? Final time minus initial time. Final time is 5 minutes, initial time is 0. So if we calculate the concentration of A and change in the concentration of A, so final concentration of A minus initial concentration of A, what is the final concentration of A is 7 mol per liter, and the initial concentration of A is 10 mol per liter. Alright. So if we put the values here, final concentration was 7 mol per liter minus initial concentration was 10 mol per liter. This is the change in the concentration of A. The result will be what? 7 minus 10 is minus 3 mol per liter. So change in the concentration of A is minus 3 mol per liter. And what will be the rate of the reaction in terms of A? The rate of the reaction will be what? Change in the concentration of A divided by time interval. The change in the concentration of A is what? Minus 3 mol per liter. And what is the time interval? 5 minus 0 is 5 minutes. So if we calculate this, this will be minus 0.6 mol per liter. Now see, here it is the rate itself is minus. You are getting the value minus. As we know, the rate or speed of anything cannot be minus value. Okay, the speed or rate of anything cannot be a minus value, but in the chemical reaction it is coming in a minus value. How this is possible? So this is also not possible to be negative rate, right? So the change in the concentration of the reactant will always be negative. Remember, because the concentration of A is always decreases, so change in the concentration will always be negative, because the final concentration of the reactant will always lower than the initial concentration. That's why you will get the negative values for change in the concentration of reactants always. So for this, the rate in terms of the change in the concentration of the reactant, we will put a negative sign before the formula. So negative, then change in the concentration of the reactants divided by time interval, right? So this is another this negative, we put a negative here, the formula. So now if we calculate this, so this is the formula negative. Change in the concentration of the reactant, suppose it is minus 3 mol per liter, and time interval it is 5 minutes. Okay, so now this minus into minus will be automatically positive. The result will be 3 by 5, it is mol per liter, it is 5 minutes. If we divide this, 0.6, it is mol per liter, and a minute here we can write per minute. Here also it will be per minute. right? So in case of the for the calculation of a rate of a reaction in terms of reactant, we'll put a negative sign before this formula, negative change in the concentration of the reactant divided by time interval. Okay, all right. So remember, this is a very important point. We have to put a negative sign in the calculation of rate in terms of the reactants, because the change of the concentration of the reactant will always be negative. Okay, and the rate will also be negative. So as we know, rate cannot be negative value, so we'll put a negative sign before the formula so that we can get the positive rate. Okay, now so in terms of the product, we'll calculate the rate in terms of the product. Suppose in the previous example, the concentration of the product was 0 mole per liter and the final concentration of the product was 2 mole per liter. So in terms of product, how to calculate the rate? Same, change in the concentration of product divided by time interval. All right. So change in the concentration of the product. Divided by time interval. Right. So change in the concentration of the product, calculate first. Suppose in the previous example, the initial concentration was 0 mole per liter and the final concentration of product was 2 mole per liter. So change of the concentration of product would be final concentration minus initial concentration. The final was 2 mole per liter and initial was 0 mole per liter. Divided by time interval was 5 minutes. So 2 mole per liter minus 0 mole per liter will be what? Again, it is 2 mole per liter divided by 5 minutes. So in this case, the change in the concentration, we are getting the positive value in terms of product concentration, and we in terms of reactant, we will get the same negative value for change in the concentration. So in terms of reactant, we will put a negative sign over here. Change in negative, change in the concentration of the reactant. And in case of product, no need to put a negative sign here. All right. So what will be the answer? 0.4 mole per liter. That is minute divided. So this we can write per minute. All right. So remember, in case of calculating of rate of the reaction in terms of reactant, there will be negative, very important point, we have to put negative over here. And in terms of change in the concentration of product, we no need to put another negative over here. Okay. So change in the concentration of the product or change in the concentration of the reactant, how to denote mathematically the change in the concentration, right? There are two ways to show the change in anything. That is, suppose the reaction was A plus B to P. All right. Change in concentration of A, we will write D third bracket A. Third bracket of A means this third bracket means concentration of A, and this D means change in the concentration of A, right? Divided by time interval is dt. This is the mathematical way to calculate the rate of reaction. But since A is the reactant, this change of concentration of A will be negative. So for this, we will have to put a negative sign here, so that this negative and this change in concentration will be negative, and this negative with this negative multiply, you will get positive value. So in terms of reactant, we have to put the negative sign over here. So this is rate equal minus dA by dt, that is minus change in the concentration of A with the time interval dt. We will have to put an equal sign here. Then again in terms of B, again B it is a reactant, negative sign, dB by dt. All right. Again we have to put equal sign here. Then we have to write the rate in terms of product. So this will be change in the concentration of product divided by time interval dt. This is the mathematical way to calculate the rate of a reaction. So in terms of reactant, we will have to put a negative sign over here, and in terms of product, no need to put negative sign over here. Remember this thing. All right.